The next part of a class that is super important is its methods. The methods are what a class does. It's its behavior, it's its functionality. It's where a lot of the value of many classes come in. I mean, certainly storing data is useful and organizing data, but what's even better is to have functionality on that data that's common in a single place. So while we have to have an object to call any method, we have to say current order, the object actually passes along that behavior back to the class. So we don't have object-specific behavior. All objects do the same thing. They all behave the same way. Think of kind of like our DNA. There's certain aspects of our biology that all do the same thing. When we're cut, we bleed, things like that. So there are ways of varying this, but only at the class level. That's a concept called inheritance and polymorphism, and you'll learn more about that in time. But for now, the idea is, we have this class. It has, these behaviors, and we access it through the object, but it's all defined in the class. So in Java, we don't have functions, we have methods. And so everything is defined as a method. To some degree, there's the notion of a function as a static method. Generally speaking, the only static method we'll show you is going to be main. It's going to be very rare that I'll show you a method. I don't think that statics are bad, but I try to minimize their use in general. So don't worry about them if you've heard about them. So every method has a name. So we have add, get, calc total, print receipt. Those are 4 names of methods inside of here. Every method has a return type. Void, line item, double, int, boolean, some data type, just like a variable. It has to return something. And they all have to have parameters. Now, it can be an empty list of parameters like in calc total and print receipt, or it can have one or more items that comes in. Every method must have an implementation somewhere. There's ways of deferring that implementation, but that's going to come between curly brackets. Now, this code is cheating here a little bit, showing a / which would not work. You'd have to do a /* in order to comment it out like this, but you don't have to have anything in here at all. I can just have open curly bracket, close curly bracket, and the method does nothing. And that's acceptable so long as it doesn't return something, which we'll see in a minute. So the lists of parameters that come in are pretty straightforward, like other languages. So we have an empty list, which is just open parenthesis, close parenthesis. I can give it a single parameter of whatever data type I want to, or I can give it multiple parameters by separating them with commas. The important thing to understand about multiple parameter lists is the order matters. So in this case, I have an integer and a string with the exact same name as a string and an integer, but these would identify 2 separate methods. Java allows you to do what's called overload your methods. And so if I define a method with the same parameter list, int and text and string, then it's going to give me an error. If I change the order of them, then it's just going to say, oh, that must be a different method. The name of the text means nothing. That's something to share information with the caller and for you to use locally as how you reference the value. But the word count, the word text means nothing as far as defining the parameters go. Parameters in general are passed by value in Java, more or less. In some languages like C, I can have a whole string I would copy in, and it would make a copy of that for the local method. In Java, strings are immutable, so it doesn't really matter, but the reality is every integer, floating point, Boolean is always passed by value, meaning I make a copy of it, I send over you. For instance, if I'm giving you homework instructions, I don't send you the original, I send you a copy. You upload it. You download your own copy of it. You don't mess with my original. Where the idea of pass by reference is, I would share it like maybe like a Google Doc, I would these days, where if you went and edited it, you'd be changing the same copy everybody's working with. So all objects in Java are passed by reference. It's just the value of the reference I pass in. So if I call some method that's available to me and I change that object, I'm changing it for everybody. So there is no ability for Java to automatically copy a object as it's passed in. If you want to give somebody a copy of something, you have to make that copy before you pass it to them. Now, inside of the method, if I have a need to return value, I identify that as a return type. I can never pass things back through the parameters, which some languages allow you to do, input output parameters or whatnot. So if I need to return something as a result of running my code, I return to you either a primitive, an integer, a double, a boolean, an array, or a reference to some class. So I can group it together and make my own data if I want to throw together a bunch of integers or integers and arrays or whatnot. So you can also return nothing, void, if I don't return anything. But if I return something, this is the way of making it happen. And then if I say I return something, I have to return exactly what I said I did by the time I reach it. Now, Java's super convenient. It's a pain when you first get started, but it's actually way easier than some languages. So I've been doing some C code on and off, and if you don't put a return statement inside of there, C will just kind of return some random value that is difficult to understand where it came from or why it's getting that value. Java will ensure that every single results of the code has to have returned somewhere. So you can see in this code, since I have an if statement, if the subtotal is greater than 0, I will return the subtotal. If it's not, what do I return? Well, probably I'd return 0 or something like that, but Java will tell me you must add a return statement somewhere. Every single path through the code must result in a return if it's there. So the logic of returns then becomes pretty interesting because the return is the last statement that happens in a method. It is possible for you to try and write code after a return statement, but Java will say to you, you can't do this. It can't be reached. Once I hit the return statement, it's done with. So if you want to print an error message, you have to do it before the return statement. If you want to see the results of a variable, sometimes you also have to save it in a temporary variable, then return that temporary variable. But notice Java also allows you to have any number of return statements. I've seen people say before if a method should have only one place to return, only one return statement. I tend to be the believer that that's nice to do if it makes sense, but not nice to do if it makes my code more difficult to read, more difficult to understand. So I tend to maybe abuse return statements a little bit, but then by doing so, it simplifies the loops or the if statements or whatnot of that I'm trying to write. Now, it's possible to use the return statement even if, as we can see in this case, there's a void that's defined. I'm going to add something void where, in this arbitrary example, if my list is full, I just return without doing anything. I don't add the product in. It's not super common that this happens, but it's allowed. You can return without having to return data. Just to stop all further actions, just to say, hey, I'm jumping out of this method, I'm going back to the caller, and I'm not doing anything further. All right, so as far as the caller goes, I can choose to deal with return or not. So the first example, print receipt, has no return data. It can't assign that to a variable or anything like that. It just returns void. So I can't say X is equal to print receipt. Items that print receipt because it doesn't return anything. I can say if it returns something, line item I is equal to items.get. I should do that, but I can also ignore it. I can ask it to total it and do nothing with the return as a result. That isn't allowed in every language, but Java is okay with you doing nothing with the return value. All right, so there's a quick overview of methods and how to build them and what they do. It's not nearly enough to tell you how to build useful methods for whatever your problem is, but at least you have some idea of the mechanics behind them and some of what the syntax means that may help you, either find the right construct you need or maybe fix the errors that show up when you see the errors that like we saw here coming out of the compiler.